What are we looking at? Alkenes. What are alkenes? Alkenes are hydrocarbons. They are what? Hydrocarbons. Hydrocarbons are organic compounds which are made up of hydrogen and carbon atoms only in their structures. They are made up of what? Hydrogen and carbon atoms only in their structures. Are we clear? But if you look at their name, the name is ending with E. So the reason why they are ending with E is because they have at least one carbon double bond. They have at least one carbon double bond. Are we clear? And the general formula for alkenes is CnH2n. Are we together? General formula is what? CnH2n. Now, for the alkene series, N starts from 2. N starts from where? 2. For the alkane series, N starts from 1. Are we together? It is starting from 1. So, N is equals to 2, 3, 4, 5, and so on. The number of carbon atoms in the longest continuous chain can be as many as positive. 5 and so on. 5, 6, 7, 8, 9, and so on. So for the alkane series, the first member is EV. EV has got how many carbon atoms? 2. So F is the prefix for how many? 2. And then the suffix is E, indicating that we have at least one carbon double bond. That's why the suffix is E. So indeed, the molecular formula is C2H4. Why C2H4? Because N is equal to 2. So you use the general formula to get this formula, this molecular formula. How do you get it? C2, N is equal to 2. C2, H2N, 2 times 2, 4. Hence C2H4, H4. Are you together? So this is the first member of the what? Alkene series. EV. The name is EV. Are we together? Now, what is the functional group in alkenes? The functional group in alkenes is the carbon-carbon double bond. The carbon-carbon double bond. What is a functional group? It is an atom or a group of atoms where chemical reactions occur. So the reaction site is known as the functional group. For alkenes, the reaction occurs between this carbon and this other carbon atom. That's why we are calling it the functional group. Now let's look at how we get the molecular formula, how we can draw the open structural formula, how we draw the condensed structural formula, and how we draw the molecular formula. How do we go about it? If the number of carbons are 3, for example, then the prefix for the name is pro. Pro is the prefix for how many carbon atoms? The prefix numeral. Prefix numeral means a prefix which indicates the number of carbon atoms which are present in the molecule. Are we together? So pro is the prefix for how many? 3. Are we together? So what is the molecular formula? C3, because N now is 3. C3 H2N. 2 times 3, 6. So this is the molecular formula. So how do we draw the open structural formula? You indicate the 3 carbon atoms. So we have 1, 2, 3. Then you put the double bond. And then between this carbon and this carbon, you put a covalent bond. After doing that, you make sure that each carbon atom is surrounded by how many covalent bonds? 4. So this one, 1, 2, 3, 4. For this one, 1, 2, 3, 4. For this other carbon atom, 1, 2, 3, 4. And since they are hydrocarbons, what do you do with the covalent bonds? You make sure that you fill them using hydrogen. So all of them are filled with hydrogen. Then you have the condensed structural formula. We start with this one. How many hits you see in the first carbon atom? 1, 2. That's why you are seeing this H2. The first carbon atom, CH. that is this CH, and then the last carbon atom, C3, which is now this C and these 3 hydrogen atoms, this C3. When you come to the skeletal structure, we don't show the hydrogen atoms. What do we show? We only show covalent bonds which are in between the carbon atoms. Covalent bonds which are in between the carbon atoms. So we have this one, this double bond here. So it means there's a carbon atom here and another carbon atom there. But the total number of carbon atoms are how many? 1, 2, 3. What is in between this carbon and this carbon? This single covalent bond, which is shown by this straight line there. Are we together? Maybe you can repeat that looking at butene. But is the prefix numeral for how many carbon atoms? 4. So we have 4 carbon atoms in butene. What's the molecular formula? C4H8. How did we get the C4H8? From the general formula. C4. 8. 2 times 4. Then it becomes 8. How do we draw the open structure? In the same way. You start by drawing how many carbon atoms? 1, 2, 3, 4. 4 carbon atoms first. And then you put a double bond in the first one. And then between carbon atoms you put single covalent bonds. After doing that, make sure that each carbon is surrounded by 4 covalent bonds which are attached to hydrogen. Are we together? So we have what? For this carbon, 1, 2, 3, 4. Are we together? This one? 1, 2, 3. Then one is remaining, which is the fourth one. Then the same thing for this. And then you keep them with hydrogen. Skeletal structure. How many bonds do you see in between the carbon atoms? First, we have a double carbon-carbon covalent bond, which is shown by this and this. This end is a carbon, this end is a carbon. But you don't show it. It just shows a double bond. Then, how many single covalent bonds? 1, 2. So you do it with a zigzag. 1, 2. So how many carbon atoms? The ends and the vertices are carbon atoms. This end is a carbon atom. This end is another carbon atom, another carbon atom, and another carbon atom. Are you seeing that? So how many? 1, 2, 3, 4. The ends and the vertices represent carbon atoms. Where you have a double covalent bond, you put 2 lines. Where you have a single covalent bond, you put a singular line. So what do you have here? Double, single, single. Double, single, single. How many carbon atoms? 1, 2, 3, 4. How many here? 1, 2, 3, 4. The same. Thank you.